My dear students, we have already seen about decoders. Now we will be looking at the decoders to compare with demultiplexer, and we will also look at how decoders can be cascaded in order to get higher order decoders, and we will also see how decoders can be used to solve any Boolean function or to implement any other combinational circuit. Okay, so as we know, decoder will be having how many number of inputs, how many number of outputs, how to design it we have seen in another video. Okay, so as we are aware that there are n to 2 power n lines, there are n lines of inputs, n lines of inputs. In our case there are 2 inputs and 2 power 2 outputs. Okay, so it is nothing but n times 2 power n, where is n is equals to, here in our case n is equals to 2, 2 power n is 2 power 2, 2 power 2 is 4. So 4 lines, d0, d1, d2, d3. How it works is it can be having active low inputs, active low outputs. That means to say I can have low low or low high or high low or high high. Now what we are looking is high high. What is this high high is inputs are high logic, outputs are also active high logic. I mean to say active low, active low, active low, active high, active high, active low, active high, active high. Inputs are active high. When inputs are 0, 0, this will be 1, rest all will be zeros. Okay, where this is LSB and this is MSB, least significant and most significant. Next time I make 0, 1. When I make 0, 1, okay, what is the value? MSB is 1, means it is 2. So second line will be 1, rest all zeros. Let's suppose both are 1s. 1 plus 1, how much? 3. So this will be 1, rest all are zeros. When D2 is 1, rest all are zeros. When D3 is 1, rest all are zeros. Likewise, at any instant of time, either D0 may be high, D1 may be high, D2 may be high, or D3 may be high. It purely depends what is being applied. If 3 is applied, 3 will be 1. If 2 is applied, 2 will be 1. If 1 is applied, 1 will be 1. What is 1? 1, 0. LSB is 1, MSB is 0. That is 1. So D1 will be 1, D1 will be 1, rest all will be zeros. Likewise, you will get your truth table. What is the truth table? Input output relations. For a given set of inputs, what exactly the output is this for a decoder, right? So is this decoder is having any enable input? There is no enable input. So what generally we do is we do add an enable input to this. So the question comes, sir, why enable? Yes, enable, if at all I have enable, if I am working with this, okay, then I can enable it. If I am not working with this, I will disable it. That means this is not going to function, it is not going to consume any power. Okay, only to save the power we will be having extra enable. So this circuit, decoder without enable, decoder you can also build with enable. If it is there enable, this enable will allow us to cascade decoders to get higher order decoders. In one way it is useful. The other way it is useful is to save the power. When we are not working with it, just I will make this 0. Okay. Once again, this enable can be active high logic or active low logic. Because I am not showing any bubble over here, it is active high logic. That means if input is 1, decoder works. If input is 0, decoder is not going to work. It gets disabled. Okay. So with this, of course, the same table whatever I am getting here, we have discussed. With enable input. So with enable input, what is the difference? When enable is 0, all outputs are zeros. When enable is 1, it is function. And what way? For 0, 0, D0, 1. For 0, 1, 1 output from D1. For 2, it is D2 output. For 3, it is D3 being 1, rest all being 0. So what is the expression for D0? D0 expression, is it not enable x bar y bar? Yes. What is D1? Is it not enable x? What exactly we have? X and y. So what is what is LSB and what is MSB? This is your MSB. This is your LSB. Now when enable is 1, when x is 0 and when y is 1, your D1 is 1. What exactly this? When D2 will be 1? D2 will be 1 when E is 1, X is 1, Y is 0. Y is 0 means complement. What about D3? D3 is 1 when enable is 1, when X is 1, Y is 1. Okay. What is this? Minterm 0, minterm 1, minterm 2, minterm. All minterms are there in decoder. That is the reason why if at all you are having any function involving minterms, okay, let's suppose I have a function f is sigma m, okay, 0 comma 2, for example. How to implement that? 0 comma 2, you take 0 and you take 2, give it to the OR gate. Why? Because I have 0, I have 2. You just OR them because I want both of them. So you are going to get the output function f. Okay. So similarly, you can go for any function. Even you can go for half adder implementation. Okay. How to implement half adder? What is half adder? What is half adder? Half adder implementation with respect to function. Let's say for example half adder. So half subtractor. We know the min terms. Just we need to take that. What is that? For 0, 1 or 1, 0, what is sum? Sum is 1. So what I need to do? To get the sum, I need to take D1 and D2, just put them OR gate, then I will get what exactly known as sum. What is carry? When you are getting carry? AB. So this itself is carry. When these two are ones. So what I try to do is, I try to implement half adder using decoder. Now how to do that is very simple. I take this inputs as A and B inputs. This is enable, there is no change. I am getting outputs, of course 4 outputs. Out of these 4, if I combine these two respect to OR gate, I will get my sum, and this itself is carry. Okay. Okay. Sum carry. I got sum, I got carry. What is this? N is to 2 power n decoder. It is 2 is to 2 power 2 decoder. 2 is to 4 decoder. From decoder, I am getting half adder. Similarly, one can solve using higher order decoders. You can solve full adder implementation using higher order decoders. Full adder implementation using 2 to 4 decoder is also possible. Okay. Or what we can do is we can use 2 to 4 decoders and we can build, okay, 3 to 8 decoder. How to do that? We will see. But before that, let's look at demultiplexer. Demultiplexer enable input selection lines. Okay, same thing. This enable in input itself is as enable. Selection lines are inputs, so they are also inputs. So it is same as decoder. Okay, in decoder we have input, enable input, we have inputs. Okay, those inputs we are calling it a selection line. That's all. There is no much change. So a decoder with enable input is nothing but demultiplexer. Clear? So this is the functionality we know. Combining decoders. So we are using enable to combine. See here, combining decoders. What we are doing? 2 to 4 decoder combined with 2 to 4 decoder. We have two inputs, same inputs we are using to this. We are getting an MSB. What is that? MSB is X. So when it is 0, upper decoder will work. When it is 1, lower decoder will work. So it will going to give the output. What exactly the output? What is going to happen is D0 will be 1 for this input. Next D1 will be 1. Next D2 will be 1. Next D3 will be 1. Next D4 will be 1. Next D5 will be 1. Next D6 will be 1. Next D7 will be 1. Rest are all zeros. So what I need to mention here? D0, D1, D2, D3, D4, D5, D6 and D7. 0 to D7. Right? So what we did? What we did is we have 3 inputs. We got 8 outputs. But what we have is a 2 to 4 decoder where 2 inputs, 4 outputs, 2 inputs, 4 outputs. Okay. So what I did, what we have converted it to 3 inputs, 8 outputs, 4 outputs plus 4 outputs, 8 outputs. Okay, one selection line is to choose one input to choose upper one or lower one. The other two are will choose any one of four, D0 to D3 or D4 to D7 will get decided by YZ. X will decide whether upper decoder or lower decoder, from which we are going to get a 3 to 8 decoder from 2 to 4 decoders. Okay, this is how exactly it is being done. Right. So with this, we have completed decoders, we have combined decoders, we have solved functions, okay, using decoders. Okay, we have compared this with demultiplexer. Okay, ma.